Welcome to The Explainer. Today, we're diving into our own biology to understand a really tough condition, Huntington's disease. It's a story about science, about families, and about a single error in our genetic code.
But let's start with a question for you. Really think about this for a second. What if a single gene, just one tiny piece of your DNA, could map out your entire future? What if it could tell you with almost total certainty that you are going to develop a fatal, incurable disease? This isn't some sci-fi movie plot. For the families living with Huntington's disease, this is their reality every single day.
All right, so what exactly is Huntington's? Well, at its core, it's a fatal, inherited neurodegenerative disease. I know, that's a mouthful. Let's break it down. Inherited means it's passed down through families. Neurodegenerative means it gets worse over time because it attacks and breaks down nerve cells specifically in the brain. And the way it attacks is like a three-pronged assault. First, there are the motor symptoms, the physical stuff. This includes the classic, uncontrollable, dance-like movements you might have heard of, called chorea. But it's also things like an unsteady walk or trouble speaking and swallowing. Then it hits the mind, the cognitive abilities. Things like focus, planning, and memory start to go, and eventually that decline leads to dementia. And on top of all that, there's the psychiatric side. Depression, anxiety, irritability. For a lot of families, this is one of the hardest parts of the disease to deal with.
You know, what's especially cruel about Huntington's is when it usually hits. The average age for symptoms to start showing up is between 30 and 50. That's the prime of life, right? When you're building a career, maybe raising a family. And once those symptoms start, the outcome is, it's always fatal, usually within about 15 to 20 years.
Okay, so we've seen what it does. Now let's get down to the microscopic level and figure out why it happens. It all starts with a tiny error in the code, a sort of biological typo that changes absolutely everything.
The culprit, believe it or not, is a single gene. It's called the Huntington gene, or HTT for short. And here's the wild part. Every single one of us has this gene. It's sitting there on our 4th chromosome. Its job is to make a protein that's really important for our brain cells. But in people with Huntington's, that gene has a critical mistake in it.
And this is what that mistake looks like. In a normal, healthy gene, there's a specific 3-letter sequence of DNA, CAG, that repeats a handful of times. Totally normal. But in the mutated gene, that sequence gets stuck like a broken record. It stutters, CAG, 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 over and over and over again. And that one little genetic stutter is the cause of the entire disease. So how many repeats is too many? Well, it turns out the exact number is everything. It's a game of numbers. If you look at this chart, anything under about 27 repeats and you're in the clear. But once you hit 40 or more, it's a guarantee. The person will get Huntington's if they live long enough. And not only that, the higher the number, the earlier the symptoms tend to appear. It's just chillingly predictable. So how does this get passed down? The pattern is called autosomal dominant. Now that sounds technical, but it's actually really straightforward. Autosomal just means it affects men and women equally. The key word is dominant. That means you only need to inherit one copy of the faulty gene from just one of your parents to get the disease. One copy is all it takes. And this leads to a stark, unavoidable number, 50%. If your parent has Huntington's, you have a 50-50 chance of inheriting the gene. It is a literal coin toss, and that's the risk with every single pregnancy. So because the genetics are so clear-cut, it creates this incredibly difficult dilemma. It's all about the choice to get tested. And as you'll see, that knowledge is a real double-edged sword.
Let's just pause here for a second. Put yourself in their shoes. If you knew there was a 50% chance that you carried the gene for a fatal disease with no cure, would you want to know? Would you take the test and learn your future, for better or for worse? It's a heavy, heavy question.
And the thing is, science can give you a 100% certain answer. A simple blood test is all it takes. It can count those CAG repeats with perfect accuracy, revealing a person's genetic destiny years, sometimes decades, before the first symptom ever appears. The science is simple. The decision is anything but. So what do people choose? You'd probably think most people would want to know, right? To plan their lives? Well, the reality is staggering. Look at this. The vast majority, we're talking 95% of people at risk, choose not to get tested. They decide to live with the uncertainty rather than face the potential certainty of a positive result. And why is that? Because knowing carries an immense weight.
A positive result suddenly impacts your career, your insurance, your decisions about whether to have kids. There's the huge psychological burden. And even getting a negative result can be tough. People talk about survivor's guilt when maybe their brother or sister wasn't so lucky. It's a choice that ripples through an entire family. Okay, but this story is not without hope. Far from it. Science is fighting back, both in how we manage the symptoms today and in the search for a cure. Now, to be clear, right now, there is no cure. But that doesn't mean nothing can be done. The goal of treatment is to manage the symptoms and maintain quality of life for as long as possible. So there are medications that can help control those involuntary movements. There's a whole team of therapists, physical, occupational, speech, who are absolutely crucial. And as the disease goes on, supportive care becomes key. And if you look at the arc of the science, it's actually been a long but very determined path. The disease was first really described way back in 1872. It then took over 100 years to finally find the gene in 1993. But then, look at this. In 2015, just over 20 years later, we're already in human trials for a drug designed to silence that very gene. You can see the pace is picking up, big time.
So where is all this research headed now? There are a few really exciting avenues. The big one is gene silencing. The idea is to basically create a drug that tells the faulty gene to turn off, to stop making the toxic protein that causes all the problems. Other strategies are looking at how to help the brain's natural cleanup crew get rid of the bad protein more effectively. And then you have things like stem cell therapy, trying to replace the brain cells that have been damaged. This is real, cutting-edge science.
And that 2015 trial was a massive deal. It was more than just a test of one specific drug. It was a proof of concept. For the very first time, scientists showed that it's actually possible to create a treatment that goes after the root genetic cause of Huntington's in people, and to measure if it's working. That just blew the doors open for future research.
Ultimately, the story of Huntington's is really a story about the future of medicine itself. We've gone from just observing a disease to finding the exact gene that causes it to now developing therapies that can target that gene directly. The fight against this one disease is paving the way for treating countless others. And it leaves us with this huge question. As science gets better and better at reading our genetic code, what parts of our own destiny will we choose to rewrite